If you need to get a hold of me after this, I'm at Stoker on Twitter, david.stokes@percona.com. I have a link later for these slides, or just ping me. They are also uploaded to the Percona site, so it should be available fairly soon. Okay, many years ago, I needed a database, couldn't afford the $100,000 that Oracle was going to charge. Ended up finding this thing called MySQL that didn't quite work, and it wasn't free. And then this thing called MySQL showed up, which had to be better because it had an extra letter in the name. About the same time, I found out about PHP, and that's pretty much been my career downhill from there ever since. So, quiz time. Name the database. It's open source, so we're 25 years old. Sworn at or sworn by for standard compliance issues. Has an active user community, growing popularity according to the DB engine ranks. Invented by a man named Michael who has very definite views on many subjects.
If it's not the third, if you knock out the third one, then MySQL fits all of that.
Well,
except Michael, because it was Monty.
Oh, sorry.
Ooh, I'm sorry. Is there something weird in my slide? I should have pictures of Michael Stonebreaker and Monty popping up here. But a little bit about me. Dave Stokes. I've been a technology evangelist for Percona for 16 months. Before that, I was in the MySQL community team for over 11 years. Have a book on MySQL and JSON that is available on Amazon, and started way back with MySQL. This was something that I didn't catch at the time, but the DB engine rankings showed that commercial databases were less popular than open source databases in January 2021. That is a big win for open source databases. Now, this is another chart I'll blow up in a second. If you look at the trends of the top 7 or 10 databases, the scary thing is Mongo after license change, Access, which I still don't know how they call it database, Oracle, MySQL is declining a little bit, SQL Server is declining a little bit, Postgres is the only one on the ascension. So that kind of caught my attention. So PG has a lot of interesting stuff that you don't find in MySQL. Materialized views. This is where you can go out and sample your data and keep it there for a little while. So like you want to do 5-minute delayed stock quotes. You run it every 5 minutes and it's out there. The view isn't constantly running and charging cycles against the database. Very handy. Merge was something that came out in the last version of MySQL. It lets you take a transaction log from a cache register and run it batch against the big database. And if you have matches or no matches, it lets you insert, delete, or update records. Very handy. They have 2 JSON data types. Not just one, they have 2, and they're distinctly different. They have so many different types of indexes. If you're a MySQL DBA, you're just going to shake your head and say, why do they need so many indexes? But they do. They do have better SQL standard compliance. Their window functions are much more complete. If you have a chance to watch or hear Bruce Mumgen talk this week, please go see him. He's one of the core contributors and an excellent lecturer. Sequences. MariaDB has had sequences for a while, but you'll see that they're fairly handy. It's the basis for many projects. One of the more interesting ones is FerretDB, which you can find their table out here. That's Mongo protocol on top of Postgres. And the good news for us who are DBAs, it's a little more difficult to set up and run. Upgrades can be tricky, but there's a lot of interesting features for MySQL DBAs who want to run Postgres. So the first thing I got to explain, because this is one thing that's always a little confusing, they picked a version of multi-version consistency control that is the exact opposite of what MySQL picked. I got to explain, there's a lot of things that are different, not better, not worse, just different. It's like you have 2 kids, you love them both, but one of them is a little special in some ways, the other one has problems in other ways. The basic idea is you have a section of memory and you drop memory in it, kind of like a chicken drop game at the county fair. And it keeps pointers to all these addresses. As things change, it updates the addresses, but it keeps the data out there for a while. It has a thing called an object identifier for your data, your tuple that you're running out there. That's the Postgres word for a row. And the OID is 32 bits. We'll come back to that later. I have some problems that you'll see. And as it drops stuff out there, the heap can fill up, and you actually have to come up and clean up after it every so often. Now, the cleanup is called vacuum. And there's several tools that will let you do this. You can do a manual vacuum command, and there's something called auto vacuum. And auto vacuum will take care of a lot of it. But the basic idea is you have a redundant row. Your Roomba comes in here and gets rid of the redundant row, frees up the memory, eventually cleans up the indexes. Exact opposite of what MySQL does. Now, hold on a second. No, this is good. Hold on. Let me check to make sure I have the right. No, I do. I'm sorry. I gave a similar talk last week in Chicago, and I want to make sure I wasn't shortchanging you all. So, first steps, you want to run Postgres. The big trouble here that you might find is that, unlike MySQL or Percona's version of MySQL, there's a whole bunch of different places to get Postgres. You can get it from postgres.org, you can get it from EDB, you can get it from us, you can get it from a whole bunch of other places. I recommend the one that we give you, but it doesn't really matter. The first thing I tell you to do is go out to the tutorial, postgrestutorial.com, and grab the DVD and rental.zip. It's very similar to the Sequila database. So if you're used to Sequila database, it kind of makes sense. So use your package manager to install the software. Do whatever you have to do to get running, system control, Postgres, start, or whatever it is. Once you get it running, first thing you do is sudo to run su with a dash to Postgres. So you become the Postgres user, and you run a command called PSQL. That's the main command line program. Create database DVD rental, exit out, and then run pg restore on the file that you brought down. Now you have a working database, you have a working version of MySQL, and you can take the first steps. And you don't have to tell your coworkers you've done this because you've all done it quietly on the laptop. Now, still as user Postgres, create user, interactive, minus small s, and then username. The reason I'm telling you to do this is super user, you have a couple little extra privileges, and you don't have to change some of the configuration around. If you're just learning, you don't want to go through that rigmarole. This gives you a user that you can use, and you still have the root account ready to go. So S is for super user. And as I said, this is dangerous, but you're used to MySQL. You know what to do if you blow up the data. In this case, you just reinstall and untar and recreate the schema, and away you go. So back in your new user account with super user privilege, PSQL minus D, say what database you want to use, DVD rental, and you'll notice that you get the name of the database equal and the octothorpe or hash mark. So, like I said, the Sequila database has been used in MySQL forever and ever and ever. This is very similar. So this lets you have something that's familiar enough, but just different enough to challenge you. And there's a bunch of D commands, and the most common one is DT to show tables. And in this case, you'd see actor, address, category, et cetera, et cetera. So for right now, that's all you have to worry about. Now, the second thing you'll probably do if you're experienced MySQL DBA is type in show create table, which doesn't exist. So what you have to do is /D and then the table name. And it will come through and tell you name of the column, the type, and you're probably not used to seeing character varying unless you come from an Oracle background. See collations, if it's nullable, and then the default values. And you'll see in there this thing, next value, actor ID, sequence, da-da-da. Ignore that for now. But the idea is the information's out there, just have to access it a little differently. It will also tell you what the indexes are. So all the stuff you're used to seeing from a show create table is out there. It's just in a different format. Different isn't good, isn't bad, it's different. So run a simple query. Select star from actor, order by last name, first name, limit 10. And as an experienced DBA, you're expecting that information. By the way, if you get lost, you have questions, please shout them out. Okay, second rule of database administration. Always do a backup before you do anything else. There are several tools for backups, but the most common one out there is pgdump. If you're used to MySQL dump, very similar. And here we say pgdump, name of the database, and pipe it to a file. So far, nothing revolutionary, nothing scary. If you're MySQL DBA and the other guys are on lunch break, you can handle this. You know.
Does pgdump do all triggers and views and everything by default?
I think so, but I'm not sure. At this point, I don't have any triggers and I don't have anything else out there. Yeah, here's where I explain what the various things are. So once again, it's equivalent to MySQL dump. Okay, simple restore. Become the Postgres user, run PSQL, create the database. This time I'm calling it new DVD rather than the DVD rental because I don't want to overwrite the other one. Type in /q, go back to my normal user. So, whoops. And then I run the command PSQL, and I want to talk to the database called new DVD, and the file that I want to input it from is backup.sql. So now you can do a backup and you do a restore. So you're now, for a lot of companies, a qualified junior Postgres DBA. Hey. Handy cheat sheets. There's a lot of these available. If you want to change to another collation or another schema, /c, then the database name, /l gives you a list of databases. I'll let you read through these. It's a little different from what you're used to, but you actually work through this fairly quickly. And of course, the other thing to remember, /q to exit PSQL. So now you know how to do backups, restores, and a little bit about getting information out of about the data. Something else to worry about is you no longer have auto increment. And you also learn about the serial data type. MySQL does have a serial data type. It's big int, unsigned, not null, auto increment, unique. But notice it doesn't say primary key. If you also make that a primary key, you have 2 indexes on that column name, which is in MySQL redundant, messy, and takes up a lot of time and space. But you'll see that this is kind of like what you're used to for the ints for MySQL. Now, sequences, if you're not used to them, this is something a little different. I came from a MySQL background, didn't have sequences. So create a schema called test, change to test, and I'm going to create a table called X. You'll love my table names and my column names because they're so damn creative. Table X, X serial, Y car 20, Z car 20. And if I do a /dx, it tells me that I have an integer and 2 car 20s, and the integer is acted on by a sequence. Now, with that in mind, so if I insert into that table just the 2 varchars, I will actually have this auto-generated for me. The thing back here in red, if you want to read that, it says every time I add something in here, equivalent to an auto increment, there's a sequence called X_sequence created for the column X, and it's a regular class, don't worry about that. It's just going to pull from the next sequence in there. So it's very similar to auto increment. Yeah. By the way, when you do inserts, you get 2 numbers, 0 and 2. The numbers represent the OID and the count. OID is always going to be 0. I don't know why. I can't really get a good reason. It's a legacy thing. But the count of records in there is what you want to look for. Of course, that's generated by server. So if I want to take a look at the table and sequence that were created by this, and I do a /d, it will show me the table, name of X, and it will also say the X table, X column, there's a sequence, and that it is a sequence. So something else you do with a sequence is you'd say, okay, start at an X value. And here I create a sequence starting with 1001, and the next value just happens to be 1001. Magic. Now, where this gets cute is that when you're inserting data, the easy way to get things inserted if you're doing it in a batch is just say next value of the column name, automatically put it in there for you if you have to explicitly name it. Now, when you need to create data real quick, the great thing about this is I can create a table and the table is actually made up of selecting a series 1 to 100 that I'm going to call ID. So I've now created a table with 100 rows in it, and they have the values 1 to 100. When you're making test data, this can be extremely efficient. Wrapping sequences. Create sequence, wrap underscore sequence as an integer, minimum value 1, max value 2, cycle. The keyword there is cycle. So I select the next value, get 1. Select next value, get 2. Select next value, I get 1. Select next value, get 2. If you have things are made up of repeating component numbers or something like that, very handy for sequences. And by the way, if you do /d order ID, that first one started at 1,000. You can tell me it's going to start at 1,000, and the maximum is going to be that 9222 number, incrementing by 1, doesn't cycle. This one, integer, start at 1, minimum 1, maximum 1, increment by 1, cycles yes. If you want to see just sequences, it's /ds. Okay, explain. How many folks here use explain all the time? And okay, it's a little different. Once again, different is not better, not worse. It's just different. You're used to seeing stuff like this, where the query plan is down here, possible keys, key length, reference numbers, rows, all that sort of stuff. This is just different enough. We're going to create 2 tables, basically the same. The difference is that T1 has a primary key, T2 does not have a primary key. So if I run explain analyze, notice analyze is in parentheses, different, not better or worse. Where ID equals 101 without an index, it will tell me I'm doing a sequential scan on T2. The startup cost, the start before you can actually start doing the query, is 0. The final cost is 1693. It's going to read 1 row. The output of that row is going to be 4. Then the stuff from the explain analyze, the actual time and startup and run and data. Rows removed by filter, planning time, execution time. Similar, not the same. Now with an index, what's great, it comes back and tells you index only scan using the name of the key on the table and the various costs of startup and execution. So it's similar. In some cases, it gives you more information. It does tell you the cost before the query actually runs. So if you have setup time where it has to join a whole bunch of stuff, you'll see that number climb.
Is the explain analyze expensive for T2?
Not really.
Okay.
Let's see. The only other thing that you have to get used to is putting the options like buffers or analyze or all that in parentheses. By the way, there's no YAML or XML output like MySQL can do in the latest versions. So learning to read the output explain, it's very similar. This slide was mainly for a bunch of PHP programmers who aren't used to running explain, but it will tell you each time it has to do a sequential scan within a hash and the various costs for startup and final processing. So very experienced DBAs will tell you when you need to change indexes. MySQL, you have one index, you love it all. In Postgres, you can see there's a whole bunch of other indexes. Sometimes you can change them around. Okay, big change is architecturally, MySQL has a series of threads. You want to run a new query, you attach through a port to a thread, push the query down the pipe, get the answer down the pipe. Postgres, you connect, unless you're using a connection pooler, a new process has to start on the operating system, then be handed off to the database, then it will take your query. On busy systems and older systems, this can be a lot of overhead. So everyone uses a connection pooler. Vacuum, a little bit more on vacuum. Now MySQL uses a different approach for MVCC. What it does is when you replace a row, it puts it in the redo log, puts the new data in there on the index, and away you go. The vacuum reclaims storage from the dead tuples, and in the Postgres operation, they're not deleted right away. So they sit out there and they can clog up memory. So you do have to run vacuum periodically, especially on frequently updated tables. I really recommend reading the Postgres documentation on this, as it explains a lot of the process that's going on. Now, luckily, for a lot of us in the last several versions, they've had a thing called auto vacuum. And vacuum goes through, it gets rid of the dead space. Auto vacuum runs by itself. It can be interrupted by other processes. So once again, reading the man page. You run this to recover or reuse disk space. If you're used to NODB, where you can clean up stuff, it doesn't quite recover the disk space for you. Also, when you run vacuum, it updates the statistics the optimizer uses. Also, there's a thing called a visibility map. We'll get into a little more detail later. It speeds that up. And the first time I'm going to introduce the dreaded transaction ID wraparound. But I'll cover that in more detail in a minute. So let's create a table called foo. And we're going to search into foo values 1 and 1. And update value, the value for the value 3 times. So we've had the original row, 3 other rows come through. And if you do a check by going through the system information, table foo has 3 dead tuples out there. And when you run vacuum, it goes through there and it will tell you that they've been erased. Visibility map is the way the system keeps track of which pages contain tuples that are known to be part of an active transaction. It seems kind of helter-skelter from the MySQL background, because why does it need a separate list to keep all this? Why isn't it just pulling it from the clustered index? It's just the way they do things. Now, having this map, the vacuum can skip pages that it knows are part of a transaction. So if something's long running, it doesn't try to clean it out when it can't be cleaned out because it's part of a transaction. And it's also smaller than the heap, so some things will actually read the visibility map before it reads the heap, which can speed up processing. Okay, transaction ID wraparound. It uses a 32-bit signed integer. If you're a MySQL DBA, you're going, why don't they use unsigned? No, they don't have that concept in Postgres. So you do a transaction, do another transaction, the XID bumps up. Eventually it can roll through all 32 bits. Once you do that, unlike MySQL, which stops because you fill up the auto increment, Postgres goes, go ahead. We'll keep all the data out there. It's just you won't be able to read the old stuff. Now, there are people who can go back and read the old stuff. It is a dark art. There's cannibalism and human sacrifices involved, and you need a new moon and flesh virgin blood, but I won't go into that. So the trick is you want to go out and run vacuum on your tables as much as you can. Some people say when the XID count reaches 1 million, you should be running vacuum anyway. So be careful. Another recommendation you'll see right from the manual is make sure you run vacuum every 2 billion transactions. Please run it much more frequently. I feel 1 billion is probably too many. So wherever you feel comfortable with that. Plain vacuum, if you do vacuum full, it goes through and hoovers up everything that you want to do. If you just run plain vacuum, it can get stuck and not reclaim everything you want. Vacuum full rewrites the entire contents of the table to a new disk file, which is a bit of an overhead. So be careful on disk space. Auto vacuum, to make sure it's running, just type show auto vacuum. Hopefully you'll see on. If you have a lot of write-heavy applications, it will preempt auto vacuum. So you need to be careful there. Also, there's other tools out there that will let you clean up the tables and the visibility maps, reindex cluster, and PG repack. Alex should like this one. He actually was bug number 2 in MySQL, that MySQL does not make toast, and he actually solved that bug. You can ask him about that that later. He can make toast with MySQL. Like NODB, if something's too big for a row, toast is how things get overextended. So once you fill up the row and you have a blob or something like that, you'll hear toast. It's same as what NODB does to extend rows. The only trouble if you're hungry on a work morning and the PG day admins start talking about toast, you get hungry. They're not talking about food, they're talking about toast. Other thing I recommend is use roles. MySQL's had roles for the last couple of releases. They're really handy. In the old days, you'd get someone new in accounting and you'd copy someone else's who works in accounting's account over in their privileges, except the new person shouldn't be allowed to delete things, or the person you copied from is the super user in that department, and suddenly the junior person's making you do backups and restores all the time that you don't like. Roles are handy. If you have someone who's working in accounting, you set up an accounting role and you assign user Jim or user Jill to the accounting role. It makes life much easier. By the way, when you do that and you have a bunch of accounting folks and you have a privilege you want to take away from them, you just take it away from the role. You don't have to go back and do it to every person. Okay, wow factor, the things that a MySQL DBA will be impressed by. Filter. So imagine you're doing a select from a table and you just want to get the values for movies that have an R rating or a PG rating. I find that type of thing very, very handy. Materialized views, I mentioned earlier. You go out there and get the data, and then you can refresh the view. Meantime, everyone who accesses this view gets the same data. So if you're doing stock quotes or reading from morning inventories, everyone has the same data, can make the same assumptions.
So there's no system refresh on materialized views?
Not until you type refresh materialized view. By the way, MySQL does have a project that does materialized views, but it's not part of the mainstream. It's an outside project. Okay, this is where the MySQL folks really feel shortchanged. Postgres has B plus tree indexes like MySQL does. Fine. Then they have hashes. MySQL's had hashes for a couple years now. SPGIST, GIN, and BRIN. Each index type has a different algorithm. This is related to different type of queries. With BRIN and sometimes GIST, you can actually roll your own index if you want to make your own index because you have something crazy you want to do. And by the way, you don't have to index the entire column. You can index just part of the column. Now, we're used to B trees, B plus trees, seen them for years, and they work the same as in MySQL, more or less, and it's the default type. So let's create a table, put in some information, and when we create an index, you see that it goes through, and in this case, it's doing an index-only scan to pull out the information. That's for the index value. You don't have to dive in the data. You can pull it back from the index. Bad example is you're trying to do a select and you're using a function in the where clause. Now, in this case, that index we just created can't be passed to the optimizer, so it does a sequential scan. So, what you can do is create another index with a functional index on that ID, and suddenly it picks up a bitmap index scan on that new index. Bitmap index scans are used when index lookup might generate multiple hits on the same heap. The bitmap really speeds stuff up where it works. In a heap where you have a lot of duplicate data, this is really amazing. And as it says there on the bottom, the optimizer does this for you. Yay. Okay, the hash works very much like MySQL hash. It takes one table and creates a hash code of it, and then it reads in the other stuff, does equity comparisons and only equity comparisons, no greater thans, no less thans. And once again, it has to have the equal operator in there. Okay, gist. This is where things start getting weird for MySQL DBAs because we're kind of out of our depth. This is an infrastructure which has many different tree-based indexing strategies. R trees, B trees, int arrays, T search, L trees, H stores, and cubes. I could probably talk for about 15 minutes for this, and it's horrible. The talk you want to hear is Bruce Momjam's talk on indexing. I think it's tomorrow. This is one of those things that is like a Swiss Army knife of indexes. They're capable of optimizing nearest neighbor searches. So in this case, if you're looking for a longitude and latitude, it will probably end up being a gist. In this case, we're looking for the 10 closest places to the point 101.456. Supports data types that are loosely coupled values like TS vectors, JSON-B. This is how you index JSON data. Normal JSON column type does not get indexed. Works with multidimensional arrays, range types, network things. If you're running a calendar and you want to exclude a date, you can use this type of thing. And anything you try to put in there will be excluded. SP-Just is for more geographical information stuff. And you can actually find out on your system what type of sub-indexes it has out there. So you can do network stuff, boxes, points, quadratics, ranges, and text. Gin is an inverted index for things like arrays, and it's similar to MySQL's multi-valued array index. Key is stored with many row pointers, very handy for arrays. Block range indexes store summaries about values in consecutive physical blocks. So if you're writing your own disk manager, you could actually do it within Postgres. As you can see, it only supports the less than, equal, less than, or greater than or equal, and greater than signs. Very, very small indexes for large tables. So if you're on a system with very, very low memory, you have some semi-embedded application, use those. It's literally 3/10,000ths the heap size of the heap, so it's very, very compact, very inexpensive to update, and they are a little bit slower, but for size, you can't beat them. By the way, the size is usually in kilobytes, not megabytes. In this example, you see I have different indexes. You know, it's 24 kilobytes, 24 kilobytes, 21 megabytes. Yeah. Remember B tree for unique values, Brin for indexing of many columns, Gin for data where you have lots of duplicates, and SP-Gist for geographic, and Gist for everything else. They do have functional indexes, just like MySQL. So that's not a thing. There are functions out there to let you find, oops, that should not be part of this presentation. Okay, suggested reading on indexes. I guess these are out there. Yeah, these are ways to find unused indexes and duplicate indexes. I'll give the address for the slides later. Suggested reading are these two documents. Bottom one is the Postgres manual. The other one is from Bruce Momjan. This is what I call the, oh my goodness, how do we still have this problem in 2023 issues. The replication for Postgres is nothing like what you're used to. There's nothing equivalent of InnoDB cluster over multi ranges. It's coming. The version that comes out in beta this week has a connection pooler and load balancer built in. So yeah, you'll see why that's important in a minute. It's getting there. Give them a couple of years, they'll have the equivalent InnoDB cluster.
Oh, they're pretty new. They're still getting into it.
Most of the times you're going to want to run a connection pooler. PG Pooler 2 is probably the closest one. Here's some reading that I recommend that you go out there. And the top one is a series of videos I've been doing on Postgres for MySQL DBAs. And remember, it's different. It's not better. It's not worse. Try to get above the fray. The folks from OtterTune wrote an article a couple of weeks ago about the parts of Postgres they hate the most. It's good reading. a second one, 9 ways to shoot yourself in the foot with Postgres. If you can avoid doing that when you're starting off, I recommend that. And by the way, when you shoot yourself in the foot with Postgres, you're using a shotgun, you're not using a BB gun. The bottom one is a partner company of Percona's where they do serverless Postgres. And with that, I want to thank you. If you want a copy of the slides, ping me later or go to speakerdeck.com/Stoker. I know they're going to be up on the website. I haven't posted them up on there today. Normally I post it with the name of the show. I've been kind of busy. Give me a couple hours tonight and they'll be up there. And with that, are you all qualified Postgres DBAs now?
Sure.
Or feel better about it?
Spell it and everything.
Can I get a certificate?
Yeah, Alex will give you a certificate. So, but if you've been playing with MySQL and you're curious and you want to go play, it's like I tell students all over the world: find an old computer, load it up, and if something goes wrong, you've lost opportunity, time, and nothing else. Great joys of open source databases is they are free. You can experiment. You might love it more than you like MySQL. It might be another tool in your arsenal, or it just might be, woo, that's okay. I'm going after something else. So, yes, Alex.
What is faster? MySQL or here?
Depends on the application. Now, usually Postgres books are heavier than MySQL books, and when you drop them, you expect the MySQL books to not be as fast, but it turns out the books when you drop them are the same speed. So
Wow, I love it.
Galileo was rolling over his grave over that. Yeah.
True or false? Like my Postgres is better than MySQL in like analytical type of queries.
The things like window functions and a lot of the analytical functions are a lot more complete. MySQL window functions have about this many things. Postgres has this many options. Once again, Bruce Momgen has a wonderful slide deck on his website about that. The general answer is that Postgres is going to be better for analytics, but it depends what you're doing. I mean, if you're doing simple sums or quartiles like that, either will do. So, geospatial, the stuff for MySQL is good. PostGIS is better. And you can find books, plural, on PostGIS. I could not pry from the developers at Oracle when I was working for Oracle any information how to do stuff with their graphical information system.
We use it in MySQL.
Yeah.
Yeah, I've got the geospatial
Yeah.
cluster running right now in my
Cool.
MySQL.
I've had some luck with it, but I said, okay, if I want to write a book on this, where do I get the information? Or if I want to write a how-to article. And
Well, just getting it built was not fun.
No.
Yeah.
And upgrading it, it can be incompatible between versions. So that's what I found.
Yeah. Well, they started using the Boost two-dimensional libraries in 5.7. No, in 5.7. Went to the 3D-dimensional libraries in 8.0. And those are the ones where I couldn't get any information on how to do stuff.
Well, we're in 5.5, so.
God bless you, sir. We'll take up a collection later. That's something we should do at one of these shows is have a GoFundMe for the folks running 5.5 and 5.6.
We're not on 5.1 anymore.
There's a company near me that's contractually obligated to run their data on 5.5 for another 2-3 years because the contractor's written, you will run it with PHP 7.1 and MySQL 5.5.
Oh, wow.
Yeah, and it's one of those things where it's like, is this lawyer still in more than one? Is that lawyer in one piece, or he divvied up their body into little chunks and tossed it to the four corners of the wind? So next year when you come back, you're now going to have Postgres talks about all the stuff you learned as novice MySQL or Postgres. Could happen, yeah.
So that means I allow developer to spin up another 20 Postgres database in another computer.
It's professional career development.
I like how you rephrase myself.
Okay, so this slide deck isn't at speakerdeck.com yet?
It will be there tonight. Or you'll see Percona Live, all that. It is up on it should be on the website for the show. But give me a couple hours to get this up on.
Cool.
My first experience with Postgres, negativity started out with out of vacuum wasn't catching up.
Mhm.
And so the XIDs got 99% full. And thankfully our contractor caught it before it got to 100%. and I thought, wait, what? Why is this still? This is like, I don't know, early '90s programming. Why did they do this?
They are slowly taking care of it. I think it's called Edge DB, where they're taking care of a lot of these bloat issues. And a lot of folks on the core team are saying, well, maybe that's what we'll adopt. We need to study it a little bit more.
And I know it's, it comes from legacy and it totally works. And working is the most important thing.
Yeah.
And it also works at scale. It can get real big. Ours is huge.
Yeah.
So,
Well, the other thing is where MySQL has some manager that says we need X, go out and create function X. Postgres is done by email. You get on an email and say, hey, I want to do this. Well, we tried that before, it didn't work. Well, I'm going to try it this way. Well, that will work, but have you tried this? So it ends up being a long-winded discussion. But when the software gets delivered, it's well crafted.
so there's no commercial body behind Postgres? I actually haven't looked.
Not really anyone driving the horse forward with a whip. It's more like, hey, let's try this. Yes, sir.
You haven't mentioned, I may be missing that, you haven't mentioned the configuration functions.
Well, I thought for someone just starting off playing with Postgres that we'd get them running and playing with the tables and then come back and talk about the PGHBA table and all the other configuration stuff like that. This is more like I get you riding on the bike and teach you to ride straight down the road, and then we tell you how to turn left and turn right and all that.
For MySQL, default configuration, you need to configure 5 variables or 3 variables.
Yeah.
And for PostgreSQL, you can run defaults, or you need to still configure the name,
At the beginning level, you can run with the defaults and it runs fairly well. It's when things get pushed to shove and performance starts working that you really start reading through the documentation and going, oh my God, why did I leave access? But
And performance-wise, I see that Postgres will be much less performant for the read workload, right? Because there's no compared to Unity, right? Where Unity is organized around primary.
Yeah.
This is just
well, the old adage is that MySQL is going to be faster for reads and Postgres is going to be faster for writes, but it depends on your application. So,
But for writes, I can totally see insert being faster because it's just dependent
Yeah.
on the file. But for update, MySQL do in-place update. Yes, undo still needs to be updated, but it can be done with memory.
Yeah.
Fix the memory.
here it's just done on the heap. They just throw another record on the heap.
No. Postgres is doing copy and write, right? Am I
Yeah.
right?
Yeah.
So Postgres will do copy and write. So it will create a new whole new work instead of just doing update and copy the previous code.
Yeah, it puts it out in the write-ahead log and I believe in 8K segments. And it actually works.
Right. Yeah. But I would expect that would be slower compared to in-place update.
Yeah.
The memory and update.
Yeah, but it's just a general old wives' tale. Is MySQL is going to be faster for reads and Postgres is going to be faster for writes. I'm sure it's just that an old wives' tale. So, yes, sir.
How about the replication? I really want to know a little bit more about, because I have personal experiences of how you set up a replication for Postgres. I'm ending up shutting down a primary instance and copy all the file over and say pointing to the wall file, something called wall file.
Yeah,
And then
That's the write-ahead log.
running, and that's my experience about it.
Uh,
But in reality, in somebody else's production environment, is it really useful high availability, or is it useful at all?
they're catching up in replication with Postgres to MySQL. The guy to talk to is Charlie Batista, who will be out the experts thing. He'll show you how you can make Percona work as fast as NODB cluster. He hasn't quite convinced me, but he's close.
We tried it. It was hard.
Yeah, it works, but like I said, they're a couple of years behind, and once they get rid of the bloating issues and they get something like NODB cluster, I think they're going to be, this far superior database. Now they're superior in a couple areas. MySQL is superior
Data
in a
types
fewer.
and indexes like crazy, yeah.
Yeah. But once they get things like JSON table, they get replication straightened out, they're going to do fine. So, yes, sir.
When you mentioned earlier about how the indexes don't have to index the entire column, what does that mean?
Say like you have a bunch of repetitive data in a column, like status 1 is fixed and 2, 3, 4, 5 is various levels of severity. You don't want to search on the ones that are fixed because that's out of your hair. You want to be able to search on the ones that are level 2, level 3, all that. So you just tell the index, don't look at the level 1s.
So a range index?
Yeah. It's one of those things where you go, that's crazy. And then you go, yeah, I have about 15 needs for that.
Yeah.
Yes, Alex.
So what is inside this wall file? Is it closer to viewpoint or is it closer to repo?
I think it's closer to the redo log, but I really couldn't answer that. But the idea is you change a tuple and you write the information out to the write ahead log, and it keeps that data. And if it rolls back, it knows how to.
So in redo, it's a diff, and I think in the wall file, it's not a diff.
It's the actual data.
Yeah. So
So
Small transaction log or something like that?
it's a,
the diff.
the write ahead log, yeah.
Yes. Right.
Yeah. Yeah. I should have mentioned it. If I think about it, I'll put it on the slides. Not version 15, the latest that's out, and 16, which is coming next week, but the internals manual for version 14 is out there, and it's a free PDF. So if you really want to dig through that, that will have all the gory details. And it was just translated in English from Russian.
Oh, wow. We're on 9.6, so
Ooh.
hey, it's solid.
Oh, it is, yeah. I had a job many years ago for an online recruiting company, and I think it was version 8. And the reason I switched everything over to MySQL is I needed replication.
Yeah.
And back then, replication in Postgres was done with triggers, which didn't always fire.
Symmetrics DB. Yeah, that's
Yeah.
how it works.
Yeah.
You replicate through triggers.
Yeah, cool.
Is trigger still a good idea in Postgres, or is still a hard no?
Oh, it's great.
Like MySQL.
It's just there's a cost, so it can easily overwhelm your database if you don't control it.
The question is, where do you want your business logic? Do you want it in your application or do you want it in your database?
Yeah.
If I go to the table and change column T1 to 5, and I look at it again, it's turned to 7, and I have no idea, so I set it to 5 again, it turns back to 7. You can chase your tail that way. Other companies I know do all their business logic in the database because they ensure that no matter what the programmer sets in, the data gets set to a known good value.
But those are normally proprietary database. In MySQL, in my entire MySQL career, I would say no to any trigger, any stored procedures, any custom.
Yeah, I've used them. They work okay, especially with check constraints out there. They're great. Now, if you want scary, go to the Postgres 15 manual page for the merge function, where you have data where you read on a line, you can either make an action or no action or delete the other line from that. But the orders of when the various triggers fire when makes the rules for the football playoff in either American football or European football seem very well thought out.
That sounds like assembly language.
Yeah. It's like there's no op, and then you do a jump back 3, and it's like, okay, I just jumped back before the no op. What's going on here? Well, thank you all. If this is your first Percona Live, welcome to the family, to the community. And make sure you go to the reception and get your card stamped so you're entered into the drawing tomorrow night.